This video is a continuation of the previous video on solving logarithmic equations and expressions. So we're given here 2 logarithm of negative 2r to the base 7 equals 0. Then we need to solve for the value of r. Alright, to solve this, we just have to divide both sides by 2. Then we are left with logarithm of negative 2r to the base 7. We should use put this in a parenthesis. Then to solve for the value of r here, we can write this logarithmic equation in its exponential form following the logarithm rules. This would be 7 to the 0 equals negative 2r, and this is just equal to 1 equals negative 2r divided by negative 2. Therefore, the value of r is just equal to negative 1/2. Okay, let's solve another problem here. Logarithm of negative m plus 2 equals 4. Okay, to solve this, we'll just subtract 2 from both sides. Then we are left with logarithm of negative m equals 2. Then since the base here is not given, so it's understandable that it's a common logarithm and the base is equal to 10. And then we can write this into an exponential form. So this is 10 squared equals negative m. And then we divide both sides by negative 1. Therefore, m is just equal to 100. You might be confused because this one, the given equation here, logarithm of negative m plus 2, you might think that this is logarithm of negative m plus 2, but it is not enclosed in a parenthesis. So that means positive 2 here is separated from the logarithm of negative m. Then let's solve another problem. Logarithm of negative 11x plus 2 to the base 9 equals logarithm of x squared plus 30 to the base 9. Since the two equations have the same basis, so we can just equate the arguments. So this would be negative 11x plus 2 equals x squared plus 30. Then we can, since we have a term here that has an exponent, we can write all of the terms in one side. Could either be the right side or the left side. Okay, so let's write all of the terms in one side. We transpose negative 11x plus 2 to the right. This would become positive 11x and negative 2. And then we group like terms. 30 goes with negative 2, so this is x squared plus 11x plus 28. And now we formed a quadratic equation. Now we can factor this equation here. So we look for factors of 28 that when we multiply them, it would equal to positive 28, and when we add them, it would equal to positive 11. So that would be 7 and 4. Okay, you can always check using the FOIL method by multiplying the binomial equations or expressions. So we equate each of the factors to 0. So we get the value of x. So that is -7, and the other one is x plus 4 equals 0, x equals -4. Therefore, the values of x here are -4 and -7. Okay, let's solve another problem here. ln of -3x minus 1 minus ln of 7 equals 2. Okay, by using the properties of natural logarithm, we can use the quotient property to solve this equation here. So we can write this as ln of -3x minus 1 over 7 equals 2. And now we can write this one in its exponential form. So when it is a natural logarithm, its base is e, which is the Euler's number. So we can write this as e squared equals -3x minus 1 over 7, and then we multiply both sides by 7, so we have 7e squared equals -3x minus 1. And then we add 1 to both sides, so this cancels out. Then we are left with 7e squared plus 1 equals -3x. Then we divide both sides by -3. Then we have -7e squared over 3 minus 1/3 equals x. So this is the value of our x, -7e squared over 3 minus 1/3. Okay, let's solve another problem here on natural logarithm. We're given here ln of x minus 3 minus ln of x minus 5 equals ln of 5. Alright, to solve this, we need to simplify this first by using the properties of natural logarithm. So using the quotient property here, we can write this as ln of x minus 3 over x minus 5 equals ln of 5. And for two functions to be equal, the arguments of each must be equal. And since they have the same basis, we can just equate them. So we can write this as x minus 3 over x minus 5 equals 5. And then we multiply both sides by x minus 5. Then we're left with x minus 3 equals 5 times x minus 5. And then simplifying this, we distribute 5 to x minus 5. Then we have x minus 3 equals 5x minus 25. And then we group like terms. So we subtract 5x from both sides. We have x minus 5x is -4x minus 3 equals -25, and then we add 3 to both sides. So this is -4x equals -22, and then we divide both sides by -4. Therefore x is just equal to both the numerator and denominator here are divisible by 2. So we can just divide them by 2. So our answer here is x equals 11 over 2. Okay, let's solve another problem here. So we're given ln of 4x plus 1 minus ln of 3 equals 5. Again, we use the property of natural logarithm. We can use the quotient property. So we can write this as ln of 4x plus 1 over 3 equals 5. And then we can write this in exponential form. So e to the 5 equals 4x plus 1 over 3, and then we multiply both sides by 3, and we have 3. 8 to the 5th equals 4x plus 1, and then we subtract 1 from both sides. Okay. This would give us, we'll be left with 3e to the 5th minus 1 equals 4x, and we divide both sides by 4. Then we get 3e to the 5th over 4 minus 1/4 equals x. So this is the value of our x. Okay, let's solve another one. So we have logarithm of 6 to the base 5 plus logarithm of 2x squared to the base 5 equals the logarithm of 48 to the base 5. So we can use the property of a logarithm here. Okay, we used the product property, so we can write this as the logarithm of 6 times 2x squared to the base 5 equals the logarithm of 48 to the base 5. So this is just the logarithm of 12x squared to the base 5 equals logarithm of 48 to the base 5. Since they have the same basis, then we can just equate the arguments. So this is 12x squared equals 48. Then divide both sides by 12. Then x squared is just equal 48 divided by 12 is 4, and then we get the square root of both sides. Therefore the value of x here is plus minus 2. So there are two values for x, positive 2 and negative 2. Okay, let's solve one more. ln of n squared plus 12 equals ln of negative 9n minus 12. Okay, since the two equations on both sides have the same basis, then we can just equate the arguments. So this is just n squared plus 12 equals negative 9n minus 2. Then we can write everything on one side. So let's move everything to the left. Negative 9n, transpose this to the left, it would become plus 9n plus 2 equals 0. And then we group like terms. So this would be n squared plus 9n plus 14 equals 0. Now we can factor this quadratic equation. So the factors of 14 would be 7 and 2. So we can write this as x plus 7 times x plus 2. So the values of our x here would be negative 7, and the other one would be negative 2. Alright, that's all for now. I hope you understood everything. The rules of logarithms, the common logarithms, natural logarithms, and their properties.